Hello everyone, this is Mr. Anderson. We're in Math Studies and we're going to look today at Learning Target 6G in Topic 6, Graphing and Interpreting Unfamiliar Functions using intercepts, vertical and horizontal asymptotes. A couple key features when graphing. We want to make our graph as specific as possible. Always include x and y intercepts. Always include any maximums or minimums. Always make sure you look at the domain and range because you might have a restricted domain and range. All right, include asymptotes if there are any, and then finally, make sure all points are clearly plotted and connected using that smooth curve. You can always check your calculator for something like this. We have a poly root finder on the calculator. It looks a little bit different on TI-83s and TI-84s. I'll show you this. It's one of those things we'll look at in class. It certainly is a helpful tool. And a calculator, even though you can't see it here, is something that I will be using to help me graph these functions. So let's just jump right into example number 1. It says, consider the function y equals 2x to the third power, I'm typing this into my calculator as we're going, minus 17x squared, and then plus 42x, and then minus 30. Now when I go ahead and hit graph here, I'm looking at a normal standard 10 by 10 viewing window, and I see something that looks pretty good, but I want to go ahead and use technology to help sketch the function. It doesn't say draw, it says sketch, which means they're not expecting to see a super accurate graph, but it should be a decent graph, all right? You should be able to get important information out of there. All right, I'm going to start by building my t-table, and because you can't see my calculator, I'm going to go ahead and I'm going to write that t-table down here. So I got my x and my y, and I'm going to get as many points as I can on this graph. So, for example, I press second in table on my graphing calculator. I'm going to start at 0, all right, and then, oops, not 0, I'm sorry, I said 0, but I'm not going to. I'm going to start at positive 1. And the reason I'm going to start at positive 1 and continue from there is because if I start at 0, my graph is going to be, my point won't fit on the graph. All right, when I enter in 1, I get an evaluation or a y value of negative 3. I get 2, I get negative 3 here again, I get negative 6, and I get 5. All right, so the first thing I'm going to do is just from these points on my graphing calculator, I am going to plot them on the graph. All right, it's just going to take a second when I do this. I go over 1, I go down 1, 2, 3, I make a dot. I go over 2, I go up 2, and I make a dot. And my graph isn't going to be as accurate as yours as I'm using the iPad here, so please forgive me. I go over 3, I go down 3, and I make another dot. I go over 4, and I go down 6, make a dot. And then I go over 5, and I go up 5, and there we have it. Now, I can see my graph. I know you guys can't. Hopefully, you're following along with a calculator, but I'm just going to go ahead, and I'm going to interpret these max and min values, all right? Part of it is going to be, oh, I'm sorry, you know what? I skipped part B. Find the axes intercepts, all right? So I got to do those as well, and I got to use my graphing calculator to do that. So in part B, I'm not going to show any work here, but I am going to say via GDC, and that just means I did it on my graphing calculator. All right, I can press second in calc, and then I scroll down to options, the 0 option, which is option 2, to find those intercepts, and there are 3 of them here. The first one is at 1.270. The second one is at 2.50, and the third one is at 4.730. Okay, so I got 3 intercepts here, so I'm going to go ahead and try to graph those things as well. 1.27, I'm going to estimate it's right about there. Give me 1 second here. Let's plot this point. I'm trying to plot it. There we go. And then I go over to 2.5, right about there we'll call it, and then 4.73 right about there. That just means I want those intercepts to go right through those points. All right. Part C, I got to graph those maxes and mins. So right here, I'm going to again use the GDC, and when I do this, it's second in calc one more time. I'm not doing zeros. When I want the minimum, my minimum value or my min is going to be at, and this is option 3 on your graphing calculator, is going to be at 3.85, comma, negative 6.15. All right, and then I'm going to do the exact same thing to calculate that maximum, and that max is going to be at 1.82, comma, 2.19. All right, so I can go ahead and lay these points on my graph as well. So I go over 1.82, I go up 2.19, and that's going to be right about there. And then I'm going to go over 3.85, and I'm going to go down a little bit more than 6, right about there. All right, so now what I'm going to take my time and try to do here is, now that I have all those points on the graph, I'll zoom in on my graph, and I'm going to make my best effort to have my function leave the graph before 0, intersect this point right here, go up through my maximum, then turn over and down through those points, and then leave before I get to positive 6. All right, now my curve isn't super smooth, and again, that's because I'm on the iPad. All right, but if you are using a pencil and paper, this is where you're now going to press graph, and you're checking your function on the calculator, and you're asking yourself this question: does mine look like what it does on the graph? And if you can say yes, then you are successful. All right, turn the page, and let's look at example number 2. Example 2 you might think is easier, and why is it easier? Check out what I just circled. It's because you have a restricted domain here. Anytime you're doing something like this, go ahead and graph it, but pick every single graphable value in this domain. So you're going to see when I make my t-table here, I'll have the x's and the y's, and I'm going to pick every value from -2 all the way up until 3. I'm not going lower than -2, and I'm not going higher than 3, because those items are not in my domain. All right, next thing, guys and gals, I want to go ahead and I want to calculate the y values, and if I do that, it is simply done with my calculator. So I enter this into my y equals, and then I go ahead and evaluate things in my table. It's second and graph brings up that table. So the first y value is -26, and then +6, and then 2 and 4 and 6 and 14. All right, oops, that doesn't look like a very good 14. Let's fix that. Okay, now if I try to graph these with a scale of 1, it's not going to fit. All right, shoot, if I try to graph them with a scale of 2, it's not going to fit. But if I jump up to 3, it's going to fit. And let me show you what I mean. All right, if I go ahead and zoom way in here, you guys can see that this would be 3 and this would be 3 as well. And what does that mean? That means that this would be 3 and 6 and 9 and 12, and instead of this being 5, we're going to call it 15. So I'm just going to make a mark out there that that is 15 and 15, and this would be then -15, and lastly, this down here would be -15. Okay, so I just want you to know what I'm counting by, and now I should be able to effectively graph. All right, so over -2 and down -26, that's going to be 15, 18, 21, 24, 26 is going to be down in here somewhere. All right, and then -1, -6, that's going to be right about there. 0 and 2, that's going to be right about there. Go over 1 up 4, that's right about there-ish. And then over 2 up 6, that's going to be somewhere in there. And then over 3 and up 14, right about there. Remember, I don't want to go any past either of those elements in the domain. All right, so my function, believe it or not, is just going to look something like that. I know it looks incomplete, and that's all right. Why does it look incomplete? Because we have this restricted domain. Of course, if I could go higher than 3, my graph would continue up like that. If I can go lower than -2, it would continue down like that. Ladies and gentlemen, one final thing I want to talk to you about, and that's what we have in example number 3, and you're going to recognize this word from Algebra 2. It's a hyperbola. Hyperbola is one of those relationships that we have where we can have a horizontal and vertical asymptote. More than likely, if it's a rational function, you will have a vertical asymptote, and that's going to be defined by this right here. And they're super easy to graph. The only thing you have to do is ask yourself one super stinking easy question. To find this vertical asymptote in example number 3, I want to know what value makes this stuff in the bottom 0, because when that stuff in the bottom is equal to 0, my function is undefined. So I'm asking, when is x plus 2 equal to 0? And because I'm asking myself that question, I'll put a little question mark there. I subtract 2 from both sides, and I know that x is negative 2 when that bottom is equal to 0. So that means my function's undefined. I'm going to go over here to the graph, and I'm going to zoom in, and at x equals negative 2, I'm going to draw in my vertical asymptote. So I'm just going to dash that line in down here. Remember what that asymptote is. That asymptote is that vertical boundary line that the function can get close to, but it can never touch. All right, so there goes that. The other asymptote is a horizontal asymptote. And in this format, just like in our exponential format, that is going to be the horizontal asymptote. Because as we get really, really, really large with this stuff, or really, really, really small with this stuff, this is going to be the only thing that remains. So my horizontal asymptote is simply going to be y is equal to 4. All right, so then I'm going to go back to my graph, and I'm going to find y equals 4, and I am going to make a line just like this. An imaginary boundary line just like that. And you can see I'm dashing it because that is in fact not part of my graph, but it is one of those things that I can get close to and not touch. All right, part B says find the axes intercepts. These are also pretty easy to find, and if you want to use your graphing calculator, they're easy to find, and I can show you how to do this. I can try to talk you through it. You can't see my graphing calculator, but I'm going to enter this into my y equals menu. Make sure you put parentheses around the denominator. So it's 1 divided by the quantity of x plus 2 and then plus 4. And if I hit graph, I can see, I think, pretty well where those things are occurring. First and foremost, let's consider where that that x-intercept is. The x-intercept is when y is equal to 0, and I can do that algebraically, or I can simply go to my calculator, second in calc, and I can find a 0, and via, let me see here, I got to do a little bit of calculating. Via my GDC, I find that it is negative 2.25. So the first one, negative 2.25 and 0. And then where is the second one? I'm going to go ahead and find that intersection. Where is it crossing? And that is when x is 0, and that is done in the table. That's going to be 0 and 4.5. I'm sorry, my pen is struggling a little bit. But I'm going to go ahead and graph those two things. At negative 2.25, that's pretty close to, I got to zoom in. That's pretty close to right here. And then 4.5 is right about there. All right, and then I'm just going to pull a bunch of other points off the graph, and I'm going to try to make 2 branches of a hyperbola that get close to those boundary lines but don't touch. And I just want to make sure that I'm going through those intercepts. And I made a mistake on that one right there, so let me erase back up, and I'll try this again. And there you go. You've graphed a hyperbola. Ladies and gentlemen, you now have the ability to try everything in Target 6G. After you're done with this, we are going to be quizzing in the next day, so come with questions. Thank you for your time. Have a great day.